So I asked one of my juniors today, can you give me the soft copy of your finals for SM015, which is mathematics for the matriculation program, since they set it like last week, I think. So one of my juniors gave me the copy of it, and we are going to try and solve it. Well, I didn't revise anything. But I'll be using a few notes, which I mean, it's not in the syllabus, but uh, critical point. Give me a few seconds. Give me a few seconds to find critical point. Yeah, I think it's because I'll be defining a few terms. Inflection point, inflection. If I have to find it, then I could explain it. Because for a critical point, I've no problem with critical points. Okay, so yeah, okay, right. So let's begin. I'll be doing this a bit quick. Not that quick, but since I am a really busy student, there are a few things I have to do. So yeah, okay, let's go. So is separated into two parts. The first part and the second part. So the first part here is about limits, and then differentiation, and then applications of differentiation. I'm not sure, but hopefully my device will not lag out. All right. So for question A, this is really simple. Since if we direct substitute the value of -3 into our function here, well, basically we are saying that as x approaches to -3, what is the value? But as you can see, we will get the indeterminate form. Yeah, indeterminate form. Wait, let me recheck whether I said it correctly. Indeterminate. I think I said it correctly, right? Indeterminate form. Yes. So if we direct substitute the value -3, then we get indeterminate form. Yes, which is 0 divided by 0, which means that essentially there is a value, but we have to use another method to find the value. So yeah, the difference between indeterminate form and undefined, where undefined is not a value we could find, but in determinate form, there is a value, but we have to find a way to gain that value. But directly substitute the value will not help us in a way. So let us try and factorize x cubed plus 27. 27 is basically a perfect cube. Am I saying correctly? Yes, it is. So limit as x approaches to -3, where x cubed plus 27. So I know that x cubed plus 27. 27 comes from 3 to the power 3, or in other words, it's the same form. And from here, I could factorize x to the power 3 to become x plus 3, x squared minus 3x plus 9 divided by x plus 3. So let me check whether that correctly. Did I do it correctly? I think I did a mistake somewhere, but let me check. I think yeah, I did something. But yeah, I think I did wrongly in sum 2x. Wait. X to the power 3 plus b to the power 3. Yeah. I'm correct. So a plus b. Yeah. So yeah, essentially I will get the value. Okay, so here assume that x plus 3 will not be 0. Therefore, meaning that yeah, x plus 3 will not equal to 0. Therefore, we could simplify this. Then from here, we are left with x squared minus 3x plus 9. Then substitute to become -3 to the power 2 minus 3 times -3 plus 9 implies that we will get the value of 9 plus 27. Wait, sorry. 9 plus 9 will be 18. 18 plus 9 should be 27. So if we check it using my calculator, and I'm hoping that we'll get the value. Okay, so that is the first part. So if we get the indeterminate form, then you should find another way to first try. Can we like make it much make another form? Then we could directly substitute the value. So for question B, so as you can see here, as usual, if we directly substitute this value, of course we will get the indeterminate form. But I have a, based on my notes, right? Let me refine it. Oh yeah, let me find it back because I have this like, it's like a what map? It's a map. No, but if I got an indeterminate form, that I should use conjugates. Yes, I should use conjugate. The conjugate of this numerator here. So what is the conjugate of the numerator? So I'm gonna multiply it by square root of x squared plus 12 plus 4 divided by x squared plus 12 plus 4. Okay, and then limit as x approaches 2. From here, as we can see, from here, it's essentially saying that a minus b times with a plus b, we should get a squared minus b squared. So from here, we will get x squared plus 12 minus 16 divided by x minus 2 square root of x squared plus 12 plus 4. And above the numerator we should get. By the way, this is not my official working. Basically, I'm just like scribbling the solution, but essentially, hopefully, based on the solution, you could have the idea on how to solve it. Okay, so x squared minus um, minus 4 divided by x minus 2 and then square root of x squared plus 12 plus 4. And then x squared minus 4, we could factorize it to become x minus 2 since and x plus 2 since 4 is a perfect square. And then from here, assuming that x minus 2 is not equal to 0, we could simplify it and then directly substitute to get 4 divided by square root of 4 16. Sorry, 16 plus 4, and then initially we should get 1 over 2. Yeah, so that is our answer. So hopefully for the first question and the second question, you'll get 27 and 1 over 2. Now for question 2, first we are going to express it in partial fractions. So a over x minus 1 square and x minus 3. We know this are a linear. This is a linear. Then and this is like a multiplicity. No. I should not say that. I am very sorry, everyone. Oh, sorry, it's not a, it's 1. Okay, then if you want to make it in a partial fractions, we should start with a over x minus 1, b over x minus 1 square, and then c over x minus 3. And then there are a few ways, but first let me combine these three fractions into a single fraction. So we will get 1 over x minus 1 square, x minus 3 is equal to a times x minus 1 plus b x minus 3 plus c x minus 1 to the power 2. X minus 3 plus b x minus 3 plus c x minus 1 square, and from here we are dividing it with x minus 1 square x minus 3. Yeah, so hopefully there is some mistakes here, and then yeah, just I will simplify this equation here, and then we will get, let me create a new page. Hang on, give me a second. wait. Oh no, wait. Let me create a new page. All right. So from here, can we solve it? That's the question. Can we solve it? Yes, we can. By 1 is equal to a times if x minus 1, x minus 3 plus b x minus 3 plus c times x minus 1 square. Alright, so there are a few ways whether you want to compare the coefficients or wait, can I at least like do anything here? Wait. Yeah, I have no issues so far. Wait, give me a few seconds to to make sure there's no personal information exposed like last time I did. Okay, so from here, um, you could let, yeah, you could let x, okay, let x is equal to, let's say, 3, meaning that I want to get rid of this term and this term here to leave me with only the c term, meaning that 1 is equal to c 3 minus 1 square. Essentially, we'll get c is equal to 1 over 4. How about if x is equal to 1? Okay, let x is equal to 1. From here, let x is equal to 1. Then we are left with the term that has our b. So 1 is equal to b, 1 minus 3. We will get b is equal to negative 1 over 2. How about a? So a, you could use any kind of value as long as your term with a in it will not be 0. So let me have a value which is the simple one. Let x is equal to 2. So 1 is equal to a times with 2 minus 1, 2 minus 3 plus with my b is negative 1 over 2, so I'm going to substitute here negative 1 over 2. 2 minus 3 plus 1 over 4. Let me write it down here a bit. Plus 1 over 4. 2 minus 1 square. And then at the end, our value of a, we should get 2 minus 3. 2 minus 3. 2 minus 1. Yeah, I should get negative 1 over 4. So basically, right? Basically, for 1 over x minus 1, 1 over x minus 1 square, and x minus 3 times x minus 3, we should get negative 1 over 4 times x minus 1 square. Oh, sorry, x minus 1. X minus 1 minus 1 over 2 x minus 1 square. And then for our c would be 1 over 4 x minus 3. So here are the values of it. Okay, so far so good. Let me check a bit. So essentially, if I want that to, yes, no, yeah, no, I need to. So okay, 2 multiply 2 x minus 1. Yeah. Hopefully, oh yeah, I forgot my plus sign here. So let me show you what happens if I combine this to become a single fraction. Then essentially we should get negative x minus 1 minus with 2 times with x minus 3 plus with x minus 1 square. Yeah, wait. Yeah, 1 over 4. Hold on, give me a second to figure out what is going on. I think I have a Oh man, I think. Oh yes, wait, no, I didn't do any mistakes, right? The X. Yeah. Oops, I forgot. This part here should be x minus 3 minus 2 x minus 3, and then this should get x minus 1 square, then divided by, I mean, this is a proper way if you want to recheck your answer. Okay. Oops, and I forgot my 4. So honestly, right, from here you should get negative x squared plus 3x plus x minus 3 minus 2x plus 6 plus x squared minus x plus 1. Simplify, you can take away that. This could be simplified. Um, did I left anything? Oh, sorry. This should be negative 2x plus 1. Yeah. That should be the correct one. So, yeah. So this will be cancelled. And 7 4, yeah, you should get the original. Okay. So yeah, this part is a bit difficult. Yeah, it took me a while. But okay. And then after expressing it in partial fractions, it wants us to find dy over dx. So meaning that we are differentiating y in respect of x. So we know our y is this function here. But we express this function into a partial fraction form, meaning that, in other words, it's negative 1 over 4 times x minus 1 minus 1 over 2 x minus 1 square plus 1 over 4 x minus 3. Okay, so we are differentiating both in respect of x. So in simple words, if I bring this here a bit to the right, then I'll put like d over dx for y. Then here d over dx for this. Meaning it's not d over dx. Essentially, I'm saying that I am differentiating both of these terms in respect of x. Okay, it's not d over dx. It's not a fraction in a way. So we should get for y is dy dx is equivalent to, all right, let me differentiate this one by one. So before I start differentiating it, I'm gonna bring all of my like terms, which is x minus 1, x minus 1 to the power of 2, then x minus 3 to my numerator, meaning that my power will also be a negative value. Yeah, so x minus 1 negative 1 over 4 minus x minus 1 squared to the power divided by 2, or sorry, this should be negative 2, and plus x minus 3 to the power negative 1 over 4. So now we have this. Now then we could differentiate it by using the chain rule. Okay, by using the power rule and the chain rule. Yeah, both things are the same thing. No, not the same thing. Using both at the same time. That should be the correct explanation of what I'm doing. So applying the power rule and the chain rule. Alright, I'll be skipping a few steps since all of the terms inside the bracket has a coefficient of 1. So I'm not worried about if I differentiate it, and since x is to the power of 1, then differentiate x in respect of x should get 1 as well. Okay, meaning that ddx of x, meaning that differentiate x in respect of x is equivalent to 1. So let us try and solve it. So x minus 1 to the power of negative 2 over 4. Yeah. And then plus 2x minus 1 to the power of negative 3 over 2. And then from here is negative x minus 3 negative 2 to the power of negative 2 over 4. So yeah, this is our dy dx. So now we want to find our second derivative. Second, oh man, I forgot the term. First derivative, yeah, we are currently going to find our second derivative. Okay. Okay, so yeah, here is dy dx, right? I mean, from here now, I might not use the matriculation syllabus if you want to find the d2y, but essentially it means that we are going to differentiate this again. That's what we are going to do. So d dx dy over dx is equivalent to d of dx of x minus 1 to the power of negative 2 over 4 plus, okay, if we simplify 2 divided by 2 should be 1. Okay, x minus 1 to the power of negative 3 minus x minus 3 to the power of negative 2 over 4. And that should be it. Now, dy over dx, if we differentiate it again, we will get the second derivative, which is d2y over dx2. Now same goes to this part here, just differentiate as usual. So negative 2 x minus 1 to the power negative 3 over 4, negative 3 x minus 1 to the power negative 4, then plus 2 x minus 3 to the power of negative 3 divided by 4. Now, if you want to simplify it, yes you can. In a best advice, if you can simplify it, then simplify it, no worries. And then minus 3 to the power of negative 4 plus x minus 3 to the power of negative 3 over 2. Now, in my opinion, I would like my powers to be positive, right? So I'll be bringing all of these terms into the denominator, which should get 1 over 4 times x minus 1 to the power 3 minus 3 over x minus 1 to the power of 4, and then plus with 1 over 2 x minus 3 to the power of 3. Now, that's basically it. If I did any mistakes, please do let me know because I'm not using any online websites to check. But later on, um, I might check it. But this is just my attempt to solve it. Okay. So it wants us to find the second derivative where when x is negative 1. Okay. So no problem. So d2y over dx2 when x is negative 1. Is that the requirement? Yes, x is negative 1. So the second derivative of this particular function, we should get negative 1 over 4 times with negative 1, 3 minus 3 over negative 1 minus 1 to the power 4 plus 1 over 2 negative 1, sorry, negative 1 minus 3. Alright, so let's go back to our calculator. Hopefully we will not get the incorrect answer. But since there is no scheme, I could not like confirm whether my answer is correct or not, but I am not that really confident, generally speaking. But yeah, okay. Wait, if I forgot, if my double derivative, it should be concave down, is it? Let me check on my decimals. Yeah, if I'm saying double derivative is less than 0 at f of prime, yeah, it does mean it concave down. So let me just type in this function. Essentially, I just want to check it because this is my first time answering it without any preparation so far. So hopefully I get the right one. So at x is negative 1, yes, our derivative shows that is decreasing, meaning yes. Hopefully is correct. Okay. Right. So yeah, that's the question that we should answer for question 2. Now, for question 3, honestly, right, it's really simple. Even though it's a polynomial of 4, it wants us to find the critical numbers. So what is a critical number or critical point or critical number? Basically, the definition of a critical number or a critical point is where f prime, I think f prime of c, yeah, f prime of c is equal to 0 or f prime of C is undefined. So that is basically what critical numbers are, or critical points, sorry. But essentially, this is a polynomial, and we know that polynomials are continuous in every point, and it's differentiable on the open interval. Yeah. It's differentiable as well. So yeah, since we know that this domain is negative from negative infinity until infinity, so yeah, this is continuous on every point, and it's differentiable at on any point. So to find the critical numbers, all we have to do is just differentiate this in respect of x. For x to the power 3 minus 24x squared plus 36 of x, and 36x, then based on our definition here, 4x cubed minus 24x squared plus 36 is equivalent to 0. And then from here we could factor this out, but I'm not going to simplify it just because I'm going to leave it that way. Oh, it's raining. Nice. Okay, from here, I'll be using the theorem, rational theorem, where this is a real polynomial and all of its coefficients are integers. So by using, people would be confused. Be like, oh, is this in the syllabus? But essentially, my goal is just to find the final answers lah. So yeah, that's basically my current goal by using any kind of method that I could think of so far. Oh, it's raining. Nice. All right, let me pull down the curtains. Hopefully, it will not be a disturbance of the video. Okay. So basically, if I think it's if P is divisible by A naught, and Q is divisible by A n. This is our like leading coefficient. So we can use the theorem. Yeah. So from here, we know that the factor of 9 is 139, and the factor of 1 is 1. So we will start with positive, negative 1. Yeah, just like this. Honestly, right, I will not be using my calculator that much unless I have to compute. Then, yes, essentially I have to. So based on this, right, I know 1 will not be the answer. How about 3? Yeah, I think I have to compute this. So 3 to the power 3. Yeah, since my critical number, my possible roots for this, the first derivative are not much. How about negative? Okay, it's not acceptable. Oops, sorry. How about negative 9? Okay. Wait. Oh my. It's about to rain. Oh yeah, there is no rational roots. Oh MG, there is no rational roots. Okay, I have to recheck my, because usually right. Usually they will like, seriously, because yeah, there's no rational roots. Okay, all right, good to know. So I think for the matriculation students, right, if they stumble upon this question, be like, there's no rational roots. How am I supposed to solve this? Yeah, but here, yeah, there is a rational root. Yeah, but why? Okay, okay. F prime of C. Oh, yes, the turning point. Ladies and gentlemen, I forgot. Yep. Okay, F prime of C means that I'm about to find the maximum, local maximum, local minimum. Yeah, but here I am trying to find the critical value. I think I've made a mistake somewhere, but I think, oh my, yep, I did. Ladies and gentlemen, okay, I am very sorry. So meaning that aku factorize the x, yep. So boom, 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 square. Ah, yes, now, yes, yes. I'm very sorry. I think, I did something wrong there. So from here, I could factorize my quadratic function here. So f of x, essentially 3, x squared minus 3x plus 9 equal to 0 for x. I think x minus 3 and x minus 3. So it's a multiplicity square. Okay. Oh, it's been 30 minutes. All right. So where are my critical numbers? Now, so basically, a point can be a local maximum or minimum. No, a local maximum or minimum. It could be a absolute maximum or absolute minimum. It could be it could be undefined. Critical point. Obviously, the definition that we are using. So two values, which is x is 0 and x is 3. So both of these are our critical values. Am I correct? Yes, I am. Yes, I am. Okay. Okay, nice. Looks like calculus works for me. So essentially, we have to like make a conclusion. Therefore, our critical numbers are x is 0 and x equal to 3. So generally, if you want to find like the turning points, because we have the terms of local maximum minimum, absolute maximum minimum, and then concavity, is it concavity? Concave up, concave down, and then we have to know the critical numbers, and then we have to know whether the point is defined or not. There's a lot of criteria that we have to follow just because we want to graph this bloody function without using our modern softwares or apps and everything. Yeah, so these are our critical numbers. So determine the points of inflection. So like I mentioned in the beginning, I forgot the definition. Here it is. So the definition of an inflection, okay, C of f of c. Yeah. So at point of inflections, from c until f of c. Oh, okay, okay. If f double prime of c is 0, or f double prime of c fails to exist. Oops. Or it's undefined, I guess. Yeah, I think both of them are the same thing. Yeah, inflection. Yeah, so inflection, I guess for matriculation students that will not be familiar, maybe they will use inflection just to know that. But in my course so far, I've learned about inflection is the concavity changes. Yeah, the concavity changes, meaning that I'll go back to my notes, right? Yeah, it changes. Yeah. Mhm. Yeah, the concavity changes. So let's us differentiate this function again. But the second derivative. So the second derivative is where is it? I can't find it anywhere. Oh, here it is. So it should be 12x squared minus 40 of x, 48x, sorry, then plus 36. Okay, then from here, 12x squared minus 48x plus 36 is equal to 0. 12x squared minus 4x plus 3 equal to 0. That just, um, sorry, yeah. So x minus 1, x minus 3 is equal to 0. So yeah, so here is the inflection points, meaning the concavity changes from con- from up. Wait, let me check again. Yeah, concavity changes. Well, it looks like it is currently raining. Inflection, x is equal to c. I think I have to like stop until here. Yeah, yeah. Section A will be enough because it's raining currently and I have other things to do. So hold on, let me find it first. Inflection. I have to check back the inflection, a point where as a tangent line where the concavity changes. Okay. So wait, let me just check back. Ah, okay, okay. Yeah, yeah. Yeah, concavity change x is equal to 1. Yeah. So x is equal to 1 and x is equal to 3. Both of these points are the points where the concavity changes. But I have to, honestly, I have to check for x minus 1. Just give me a moment, yeah. Um, yeah, at 3 it changes, but at 1, I'm not sure why it changed at that point. Yeah, let me. Oh, wait, it's not. Sorry. Oh yeah, 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 yeah. It changes. Yeah, 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 yeah. So yeah, yeah, it changes. Okay, okay. So here are our inflection points. Yeah, there we go. Our yeah. I'm not gonna. I think inflection points is it. The points of inflection. I have to like find my y values. Is it okay? So when x is equal to 1, y is equal to. I need to just substitute, right? So I'm gonna substitute. Um. Yeah. Very sorry. The current circumstances is really out of control. It's currently raining. I'm doing PSPM maths. Then x is equal to 3 and then y should be 0 if I'm not mistaken here. Um, by the way, if any of you disagree with my solution, let me know. Alright. I'm not saying that my working is yeah. If my working is incorrect, do let me know as well. Okay. So yeah. So therefore, points of inflection are 1 equals 16 and 3 0. Finally, okay, so that is about it. Um, honestly, even though I only covered like 3 questions so far, but yeah, I think that's about it. But yeah, I think my definition that I'm currently using is based on Thomas calculus. So I'm not following the current matriculation syllabus, but hopefully you guys do understand, and hopefully my calculations is correct lah. Okay, so yeah, see you guys later, and have a great one. Bye bye.